Alright, geometry. We are finishing this packet, and this is the last thing we're going to do with Unit 1 before the exam. Exciting. Alright, so transformations review. Remember, Unit 1 is all about transformations, right? We talked about 4 of them, but we talked about 3 in depth. We talked about translations, and remember that's slides, right? We're sliding up, down, right, and left. Reflections, which were flips, and then rotations, which were turns. All right, remember that translations, reflections, and rotations are all rigid. Rigid means same size, same shape, and it also means the pre-image and the image are congruent. Wow, that was a lot, sorry. Rigid, so same size, same shape, that means the pre-image and the image are congruent. They're exactly the same. That's what congruent means, right? Exactly the same. The only thing we did was shift it or slide it. Alright, so let's take a look at this and see what directions we are going. Alright, you know I'm about to hit you with that multiple choice, right, on the Edpuzzle video, so go ahead and get ready for that. Alright, when we subtract from the x value, what direction are we moving? I hope you said left. If we're adding to the x value, what direction are we moving? Hope you said right. If we subtract from the y, we are moving down. And if we add to the y value, we are moving up. Remember, the x value is first, that's your right or left. The y value is second, that's your up or down. So this is your right or your left, and this is up or down. All right, right, left, up or down. So if I'm changing the x value, I'm moving it right or left, depending on how I changed it, right? If I added, I went right. If I subtracted, I went left. I changed the y value, that means I go up or down. If I added, I went up. If I subtracted, I went down. All right, so that's pretty straightforward with the translations. Reflections. All right, reflections, we're flipping over a line of symmetry, right? So again, reflections are also rigid transformations, which means same shape, same size. I know you're going to get sick of me saying that. Same shape, same size. That means the pre-image, well, I wrote a capital R, so everything's got to be capital. Like I'm screaming it. Pre-image and image are congruent. Meaning the pre-image and the image are exactly the same, right? We did not change the size or the shape of the figure. The only thing we did was flip it. All right, so we've got some rules here. Let's take a look at these rules. All right, flipping it over the x-axis. So before, oh, look at this cool trick I learned with my document camera. All right. And yet, I can't draw a straight line. Alright, so look, if I'm flipping something over the x-axis, let me draw a nice triangle. Beautiful. Alright, if I want to flip that over the x-axis, you'll see I'm flipping it over, and again, this is not perfect, I'm just kind of showing you the general idea. Alright, so if I flip that over the x-axis, then I change the sign of the y. You see it was up here and now it's down here. So when I flip over the x-axis, I'm going to change the sign of the y. So xy is going to become x negative y. X negative y. And the equation of the x-axis is y equals 0. The x-axis is a horizontal line, and it hits the y-axis at 0. So if you see flipping over the line y equals 0, you have to know that's the x-axis. All right, if we were flipping over the y-axis, we would be going Can I erase? This thing looks like an eraser. Ooh. Alright, if I were to flip it, let's try a circle. See if I can do better with a circle. Whoa, I cannot. That looks like a bean. Alright, let's flip this bean over the y-axis. If I flip it over the y-axis, I'm going this way, right? Because the y-axis. Alright, you guys have got to give me grace on this. Alright, so if I'm flipping it over the y-axis, do you notice how I changed the x value? It's over here on the right side, and now it's on the left side, right? So I'm going to change the x-axis sign. So now I'm going to change the x-axis sign. So negative xy. And see how I circled just so I know, like when I'm looking at the rule, this is what changes. This is what changes. The other sign stays the same. All right, if I'm flipping over the line y equals x, let me get back to this whiteboard with my beans. The line y equals x is a diagonal line going up from left to right. Wow, now you can see why I'm a math teacher. All right, so it's going up from left to right because I've got no other talents. So if I want to flip over this line, we have a rule for that. The rule is that xy is going to become yx. I just flip their positions, right? Flipping the positions. All right, what about the over the line y equals negative x? Well, with that, I flip the positions as well, but I also change the sign of both of them. Both of their signs are changing, and I flip them. All right. What about other lines? All right, so we need to know how to draw these other lines. So if you look, x equals negative 1, that's going to be what, a horizontal line or a vertical line? All right, I hope you said vertical. Just think that it's going to hit whatever axis we have in the equation. So it's going to hit this x-axis. So if it hits the x-axis, it's got to be vertical. And it's actually going to hit it at x equals negative 1. So that would be my line of reflection right there. All right, what about y equals 4? That's going to be a horizontal line because it's going to hit the y-axis. So as long as you know how to draw these vertical and horizontal lines, you will be good. All right, so you're going to draw the line. After that, you're going to count how far away each point is from the line of reflection that you drew. So if it's 2 points to the left, when we flip it, we're going to move it 2 points to the right of that line. And this will make more sense when we do some examples. All right, rotations. All right, rotations, we're turning. Again, rotations are rigid transformations, meaning that the pre-image and the image have the same shape and the same size. That makes the pre-image and the image congruent. You may have heard this before. That's because that's true for all three of these: translations, reflections, and rotations. They all make the image and the pre-image congruent. They're all rigid transformations, same size, same shape. All right, so here are our rules. All of our rules have to do with counterclockwise. So remember, if we're going counterclockwise, a clock normally goes this way, right? So counterclockwise is going this way. That's what counterclockwise is, away from the direction a clock goes. All right, so our 90-degree rule, I'm going to highlight. I'm going to highlight which one we changed the sign of. So our 90-degree rule, we flip them and change the sign of the original y. So you can circle it if you need to, but our 90-degree rule is xy turns into negative yx. Our 180 rule is pretty easy. We keep them in the same position, but just change the sign of both of them. Now I know what you're thinking, that sounds like a reflection that we just did, right? Where we changed the sign of both of them. But look, for a reflection over the line y equals negative x, we also flip their positions. Y came first and x came second, so it's not the same thing. This one, we keep them in the same position. It's going to be really important that you guys have these rules beside you during the test that you can reference. All right, the 270-degree rule, we flip the position and change the sign of the original x. So xy becomes y negative x. All right. Now, all of that was for counterclockwise. All of these rules apply for counterclockwise. And if they don't tell you a direction, you can assume that you're going counterclockwise. Now, what if they tell us clockwise? What do we do? Well, if they tell us clockwise, we're just going to use one of the counterclockwise rules, but we need to figure out which one. They tell us 90 degrees clockwise. We're going to use the opposite counterclockwise rule. So we're going to use the 270 degrees counterclockwise rule. If they tell us 270, then we're going to use the 90. So see, we just use the opposite rule if they tell us clockwise. And with 180, it doesn't matter, right? If I start here and end up here, or start here and end up here, you end up at the same place going either way. So with 180, you always have the same rule, and it's that negative x, negative y rule. All right. All right, and the last transformation that we talked about was dilation. Dilation, you change the size. You're either reducing or enlarging. And we'll talk more about that in Unit 2. What I want you to know about dilations right now is that they're non-rigid. Non-rigid means same shape, different size. So, are they congruent still? Are the pre-image and the image congruent? No. They are similar only. And I know that we don't know what similar means. We're going to talk about that Unit 2. Just know that the pre-image and the image, and I should write that right here, pre-image and the image are not congruent. They are similar only with dilations. It's the only one out of the 4, which is why we're saving it for Unit 2. All right. Go and flip the page over. All right, example 7. What sequence of transformations maps triangle ABC to triangle RST? All right, so pay close attention here because you'll have some questions like this on the test. So I want to make sure we all understand this. All right, so looking at this, it looks like this is my pre-image and this is my image. All right, this is my pre-image and this is my image. So let's see which one of these actually applies. We can start at A. Reflect ABC across the line, x equals -1, and then translate the result down 1 unit. All right, well, x is equal to -1 is right here. It's a vertical line, and it hits the x-axis at -1. So remember, if we're reflecting over a line that we don't have rules for, we're reflecting over a line that we don't have rules for, we need to count how far away each point is from the line, and then count the same number away from the line in the opposite direction. So if you look, point C is 2 units away from that line of symmetry. So I'm going to go 2 units the other way and put my C prime there. B is 2 units away as well, so I'm going to count 2 units in the opposite direction. And then A is 1, 2, 3, 4, so I'm going to go the other way, 1, 2, 3, 4. You'll notice that I did not, you'll notice that's barely a triangle, but you'll also notice that I did not count from the y-axis. That's not my line of symmetry that they gave me in answer choice A. It's this right here. I counted away from the highlighted line both directions. All right, if I were to take this and shift this down 1 unit, will that match up this triangle onto this one? No, it definitely won't. It needs to be shifted down more, right? So I can eliminate A. A is out. All right, let's see what B is. B is the same reflection. Okay, so I'm still right here. And then translate the result 5 units down. Well, that could work. Let's try. So I'm right here. I'm going to go down 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. That works perfectly. B is our answer. And I would just keep working through these until I got this to match up on the triangle exactly. All right, example 8. Which transformation on quadrilateral ABCD produces an image that does not preserve distances between points? All right, this is a weird way of talking about what we know. So which transformation? So I've got reflection, translation, dilation, and rotation. Which one produces an image that does not preserve distances? Okay, that word preserve distances. Preserve means keep, right? Keep in the exact same way. So when it says does not preserve distances between points, if I'm not preserving the distance, let's say my distance is 2 units all the way around because I have a square. If I'm not preserving that distance, that means I'm making it smaller or I'm making it bigger. I'm not keeping it, right? So I could make it 4 units, or I could make it 1 unit. So if I'm not preserving distance between points, that basically means I'm changing the size. Take a minute and pick which one you think changes the size of a pre-image. All right, I hope you said D. I'm sorry, C. C is the only one that does not, C is the only one that changes the size, right? Dilation is the only one that changes the size. By a scale factor of 2, don't worry about that. We'll get into that in the next unit. All right. Example 9, rectangle WXYZ has these coordinates, the pre-image coordinates. Part A says graph the image of a rectangle after a rotation 90 degrees clockwise. All right, so we want to take all of these points and I'm just writing down the pre-image points from up here. And we want to rotate them 90 degrees clockwise. All right, let's go back to our summary rule sheet to see what 90 degrees clockwise will be. All right, 90 degrees clockwise, I'm going to use the 270 rule. All right, so I'm going to write this down. My 270 degree rule is going to be XY turns into y negative x. X is my sign that's changing. All right, now that I got this written down, I'm going to go back. And let's change all these points. All right, I'm going to circle all of the x's because I know that's the sign that's going to change when I flip them. All right, so my w prime is going to be, remember we got to flip the position as well. So 2 comes first, and negative 1 comes second because I changed the sign. X prime, my y is going to come first, and let's go ahead and just write out all the y's because I know that they're going to come first. All right, now the x's come second, and I need to change their sign. So instead of positive 3, it'll be negative 3. Instead of positive 3, it'll be negative 3, and instead of positive 1, it will be negative 1. All right, so here are my part A points after a 90 degrees clockwise rotation. So let's go ahead and label these 2, negative 1, 2, negative 3, negative 3, negative 3, and negative 3, negative 1. Alright, I connect them. This is W prime, this is X prime, this is Y prime, and Z prime. Alright, so I got all of that there. Part B says to translate the rectangle 2 units to the left and 3 units up. Alright, I can do that. Let's just take each individual point and go left 1, 2, and up 1, 2, 3. Alright, that's Z double prime. Same thing with Y. Left 1, 2, up 1, 2, 3. It's Y double prime. W, let's go left 1, 2, and up 1, 2, 3. W double prime. And then X, go left 1, 2, and up 1, 2, 3. And I can check my work because the shape should be the same and the size should be the same. We were just translating. Alright. Another way to check my work is I could have taken each of these points and subtracted 2 from the X value and added 3 to the Y value, and that would give me my new points. Alright, is rectangle WXZ, our original rectangle, WXYZ, is it congruent to this rectangle after the 2 transformations? Is it exactly the same? So part C, yes. WXYZ is congruent to W prime, X prime, Y prime, Z prime, because rotations and translations are rigid transformations. So the pre-image and image have the same size, same shape. Boom, look at you writing in math class. Alright, so I know that the pre-image and the image are congruent because all we did was rotate it and translate it. We did not dilate it. If we dilated it, it would no longer be congruent. Let me say that one more time for the people in the back of the audience. If we dilate it, it will not be congruent anymore. Dilation means they would be similar. Rotation, translation, reflection. These are all congruent. Congruent, dilation is similar. Look at that beautiful work. Alright, last one. Example 10. What is the sequence of transformations that carries triangle ABC? So triangle ABC comes first, that's important, onto triangle RQS. SRQ, my bad, SRQ. Alright, so let's see. We already had a problem like this, so let's just work out the answer choice solutions. Triangle ABC is reflected over the line x equals 3. Alright, so x equals 3 is going to be a horizontal or a vertical line, and it's going to hit the x-axis right here at x equals 3. Alright. So if I reflected it, point A would stay the same because it's right on that line of symmetry. Point C is 2 units away, so I'm going to move 2 units to the left. Point B is 2 units away, so I'm going to move 2 units the opposite direction from the line. Alright, so that's a reflection over that line, x equals 3. And we know it's on the right side because it's a positive 3. If it were a negative, that line of reflection would be over here. Alright, then it's translated down 2 units. Let's see if this works. I'll take this one and go down 1, 2. Okay, well, it does match up to point R, but this point at the bottom of my triangle should go all the way down here to Q. So that doesn't work. A is out. Maybe we'll get lucky and B will be our image. Alright, so we reflected across the same line, x equals 3. Then now let's translate it down 6 units. So let's take this point and go down 1, 2, 3, 4, 5, 6. All right, that one works. Let's take the top one and go down 1, 2, 3, 4, 5, 6. Perfect. And this one, 1, 2, 3, 4, 5, 6. How lucky are we? The second answer both times. Again, if we were just going through and continuing, we would just do this translation, and then we would rotate 90 degrees using our 90-degree rule. That's how we would try answer C and answer D. All right, let me know if you have any more questions before the test next week. All right, have a good weekend.